So let's begin, right? All right. So if you look here, here's our household circuit, right? Within the household circuit, come closer on, right? Within the household circuit, there are some important components that we need to learn about. I'll talk about them first, then I'll give you a small note, right? Okay. So let's look through here. Right. Y'all seen everything there? Nice, good. So within the household circuit, of course, you have your components, right? You have your little light switches and you have your immersion heater, your main switch, cooker, and so on, right? Right, you'll recognize some other things. Anybody recognize what this is here? Resistor, now have a line going through the middle of it. Anybody recognize that? Huh? Nah. No, I think that diode. We do diode yesterday. That's a fuse, right? Right? There's a fuse there. And we have the main circuit and supply and so on. All right, so right. So here's how it works, right? In a household circuit, you have wiring. You have three types of wiring, right? You have the blue, the gray, and the green and yellow, right? Green and yellow represents the earth. N is the neutral, and sorry, blue is the neutral here, right here, and the brown is a live wire, right? And this, huh?
It is ground. It is ground.
Yeah, it's like a ground, yeah. And your ground or your earth wire is the green and yellow wire, right? You have to learn all the colors, right? Right. What you will notice initially is that there's current entering from a supply cable, right? The current entering is generally these colors here, black and red. Right, so if you go home and look at the current coming into your meter, it's black and red. Okay, red is the live and N is the neutral, right? The purpose of the neutral is to kind of complete the circuit. So for current to flow, remember we need a complete circuit. So we have one carrying the current, one helping to complete the circuit, and a green and yellow. The green and yellow is earth, and the purpose of the earth is in case there's excess current, it will pull, yeah, it will pull it out and it will neutralize it in the earth. All right. Right. What you will also notice here is along the main switch, right? For your home, you're not really seeing it here, but for your home, what you will have is a big breaker panel, right? So you will have these like little black switches called breakers, right? That's where the initial current coming in, and then from there, you may see a wiring that's blue, brown, and green, right? Right, as I said, the brown actually carries the current. The blue is what helps complete the circuit, and the green and yellow is the excess. What you'll notice here as well is connected. In your homes, you don't have this, right? You don't have fuses. What you really have are breakers, right? But I want to show you how the fuses work as well. On all the live wires, what you have are different amperage fuses. You have a 5 ampere fuse, you have a 15 ampere fuse, 30 and 30, right? So based on the amount of current being drawn, you'll have to put in the size of the fuse needed. So for example, these 3 bulbs in parallel, they only take in a little less than 5 ampere current, right? This immersion heater is taking around 15 amperes. Your main ring taking about 30, and the cooker taking about 30. So what if you go to your breaker panel, what you will see is 30 ampere breakers, 20 ampere breakers. Per AC units, you might see 20 and 50. Yeah, so if that's anything more than that, it will cause the breaker to switch off, right? And the beauty about breakers is what? Is that when it switches off, you can switch it back on. But if it damages a fuse, you have to go find it and replace it. All right. And next thing that we notice in here, look at all the bulbs. How are the bulbs connected? Parallel, right? Because the bulbs are connected in parallel, what that does is that it requires a lower voltage to be supplied, right? Anybody knows the voltage at your home? Yeah, you have two types of voltage at your home. You have 110, that's the normal plugs that they plug in for your charger, and 220 it's like AC units and the electrical stove, yeah, right? So the voltage into your house is generally 110 and 220. The larger appliances use 220, the smaller use 110. All right. What you'll notice here is that your bulbs, so that they use less voltage, they're connected in parallel, right? There's also a next reason why we connect them in parallel. Anybody knows? So you have independent control, right? Yes, if you have it in series, like for example, those who have downlighters, those in series, you turn it on, all will come on, turn it off, all come off, right? Yes, so that is your that's basically the components of your household circuit. Okay there? All right, so head up household circuits. I'm gonna give you a small note. So let's take a look at your household circuit, right? It's a small note on this household circuit, right? Everything you can see right there, right? Stay quiet. Ready? Yeah. Household circuits, taking a small note. Household circuits. Like the one shown above. I normally ask you to choose the homework, but I forgot. Right? So you can screenshot it, or you can want to look back at the video home, you can show it. Right? The household circuit as shown above has a few key characteristics. One, I'll list them out here, right? One, the wiring in the house consists of three main wires. The wiring in the house consists of three main wires. Alive, not alive, right? Live, L-I-V-E. Which is brown. Live, L-I-V-E, which is brown. A blue, sorry, neutral, which is blue. And earth, which is green and yellow. Or ground, right? Some people call it ground. Right? Earth, which is green and yellow. Earth, which is green and yellow. Right? Live carries, live, you can use L. Right? The live carries current. Comma, the neutral helps to complete the circuit. Can you get shock from the neutral? If it touch neutral alone, no, right? But if it touch live,
Only neutral here, okay?
you bet. Well, according. Right? Neutral helps complete the circuit, and the earth takes away any excess right? Any excess current or electrons away from the circuit. The earth
Takes away any excess
right? The
current
earth takes away any excess current or electrons away. Okay, good. Number 2, fuses and breakers. Fuses and breakers. Most household circuits have electromagnetic breakers. Most household circuits have electromagnetic breakers. Electromagnetic breakers. I'll repeat that. Most homes have electromagnetic breakers, EM breakers. That are used to control the amount of current in a particular part of the circuit. For example, a 50 amp breaker. For example, a 50 amp breaker put in brackets or fuse. A 50 amp breaker or fuse. FUSC. Right, a 50 amp breaker or fuse. Right, can be used to protect an AC unit. That requires 40 to 45 amps during usage. 40 to 45 amps during usage. Full stop. Note that a breaker, Michael, I can't remember now, right? Let's leave a little space, right? Full stop. Note that a breaker can be switched on again Note that a breaker can be switched on again when triggered. When triggered. While a fuse must be replaced. While a fuse must be replaced if a current value more than its rating is, if a current value more than its rating is supplied to it. So basically, I'm just trying to say that if you trip a breaker, if a large current or a large surge comes in and a breaker switched off, you can switch it back on. But a fuse, you have to take it off and replace it. Right? Number 3. Did I ever send an electricity handout? No. Number 3. Number 3, in a household circuit, connections are generally made in parallel. In a household circuit, connections are generally made in parallel. In a household circuit, connections are generally made in parallel. Connections are generally made in parallel. To allow for independent control. To allow for independent control. And to help protect appliances and to help protect appliances, right? First up, note that fuses of breakers are connected to the live wires. Note that fuses of breakers are connected to the live wires. All right, so one last thing, because some of y'all don't know this. To our home supply voltages are the supply voltage to our homes is either 110 or 220. Just make a note of that, right? 120. Sorry, 110 volts or 220 volts. Uses what you pulling in. Remember everything noise fish on. All right, so good. Just a little idea of how household circuits work, how to connect it up, and why we have breakers, fuses, why we connect in parallel, and why we have different wiring, right? This circuit here will be a good idea for you to, yeah, Just for us, Michael, the different countries have slightly different ratings. Some countries that like England, they generally use 2 something alone. Oh, one thing I did not point out here is a 2-way switch, right? So a 2-way switch, anybody has at home where you can take off a light upstairs and downstairs? Yeah, that's called a 2-way switch. So the switch has the ability to turn on the light if you're upstairs, and when you go downstairs, you can take it off if you want. All right. So that's an example of how the wiring looks, right? For a 2-way switch. So you can turn it on or off downstairs. You can turn it on or off upstairs. Right. So you have your little 2-way switch here. All right. So nice. I just wanted to show you how that will work. Hmm? Yeah, single and 2 and 3. All right, ready? Right. Oh, we're ready for again. Right. So we did household circuits. The next thing that we have to do. Actually, you know what? Right, I'll explain it. I'll go it over again, but I did this yesterday on the electronics video, right? I kind of wanted to show you what logic gates today. That's the last part of electricity. Anyway, before I do this, watch this here. Right? We did, for those who joined the class yesterday, this thing, right? We did something called semiconductors, right? So we need to learn about the semiconductor diode. It looks like this. Right? What the semiconductor diode do? It allows current to flow in. Right? It allows current to flow in one direction only. So for example here, we have a diode. Oh, sorry, I didn't put the diode. It don't matter where you put it, right? You can put it before the bulb or after. It don't matter. Current going this way, right? When current going in the same direction as the little arrowhead here, the bulb will light. That is called your forward bias state, right? Or forward bias direction. And then you have your reverse bias. So if you look here, right? If you look here, here's positive, negative current going this way. When the current going against the arrowhead, no current will flow. That is, and the bulb will not light. That is called your reverse bias state. Okay? That's yesterday. You better remember it. All right, Papi. Thanks. All right, so that is your forward bias and reverse bias state. Right? I gave you some homework one time. I want you to read up. Actually, not read up. Watch a video from yesterday on half wave rectification. Right? I want you to watch the video from yesterday on half wave rectification. All right, because today I want to show you all the last thing in electricity called logic gates. Okay, well, this component of it, electricity and electronics, right? I want to show you logic gates today. Real easy. Half wave rectification. Half wave rectification. I showed you yesterday. And you was in class yesterday? Oh, half wave rectification. But did that here yesterday. So if you look at electronics from yesterday, you'll see it. Right, so we'll take a look at this. All right. So the only reason I rushed you because I want to show you all logic gates today. Next week, class like normal. The week after is online. That's Carnival Saturday. I might give you Carnival Saturday open. I ain't sure yet. All right. No, you sleep and you wake up Saturday like normal.
You man, you could go as next Monday and come down Tuesday.
Them going to field trip, they just walk in and come. All right, logic gates. Are you ready? So here's how a logic gate will work, right? I could show you a quick simulation, but it's simple. So watch this here. A logic gate, it takes a binary input and it gives you a binary output. Right? Binary means a 1 over 0 and it gives you back a 1 over 0. Right? So when your binary input goes in, you'll get a binary output. Right? And there are some logic gates that we have to learn. Right? So some of the logic gates that we have to learn are number 1 gate. Right? I'm going to draw all for you. Number 1, NOT gate. Right? NOT gate looks like this. A little triangle, 2 lines. Kind of like a what? Kind of like a diode, right? You have your input, output, right? Whenever the input is 1, if a 1 goes into a NOT gate, you will get 0. If a 0 goes into a NOT gate, you will get 1. Okay? You have to learn that. This here is called your truth table. Right? That's the truth of what will happen when those inputs goes into a gate. Anything else will be a false table. Right? So you have to learn the truth table and you have to learn how it looks. Actually, I'll leave out a little bubble here. Sorry. That's a little inverter in front, a little circle in front. That circle is called the inverter. Right, you have two more main colors here called the AND gate. Yeah. It's called an inverter, the little circle thing. Yes, now you'll see. Hurry, man. How are you? Yes, now you will see, Papi. Right. Take a look at the AND gate. How many inputs does the AND gate have? How many lines go into the AND gate? 2, right? So basically what you see, right? Since you have 2 going into the AND gate, you could have a 1 and a 1 going in it, or you could have a 1 and a 0, or you could have a 0 and a 1, or you could have a 0 and a 0. So you have 4 combinations of values that could go into AND gate. Right? And the answer is what? In an AND gate, 2 1s give you a 1. Everything else will give you a 0. Remember, it's binary, everything is 1s and 0s, right? So AND gate, 2 1s will give you a 1, everything else will give you a 0. OR gate. The OR gate, once you have a 1, Celine, you guarantee to get a 1. 1 1 is 1, 1 0 is 1, 0 1 is 1, 0 0 is 0. Right? That's your AND gate, your OR gate, and your NOT gate. You have 2 more gates.
Or right.
You have the NAND and the NOR.
Have a small, you have a circle in front of your data.
Well, if it kind of soak on this here, this a road march. No, who will take road march? I only hear one good song so far.
Where is it?
Like one G song. I hear nothing else.
Right, on the song.
Huh?
I'm commenting. Yeah, you remember much. Oh, that's so bad.
Ready? Right, last two. One is called the NAND. I'm squeezing it in right here because I wanted to see how similar it is to the AND, right? All it is do is draw AND gate and put a little inverter in front. Right? Real simple, input, output. So if you write down the same input, all you have to do for a NAND gate is flip around the output. Right? So it could be 0, 1, 1, 1. Right? And then you have one more gate. That gate is called the NOR gate. You're drawing the OR gate and you're putting a bubble in front. You have your input and you have your output. Right? If you had to guess, what would the output be on Keshav for the NOR gate? Just the output.
Anything with 0, you have a anything with 1 or 0. Anything with
Keshav is the opposite of the OR, right? So when here is 1, here is 0. Right? 0, 0, 1. Yeah, Dimitri, you got you there, Dimitri. Okay, so those are the 1, 2, 3, 4, 5 gates you have to learn. Now we're going to combine them. Right, sometimes for some people it might be kind of hard to learn, so I'll give you a short version for each one, right? All right, it's here in black. For NOT gate, it's always the opposite. For AND gate, 2 1s giving you a 1. For the NOR gate, 2 1s giving you a 0. Sorry, for NAND gate, 2 1s giving you a 0. For the OR gate, all you have to remember is a 1 will always give you a 1. And for the NOR gate, all you have to remember is a 1 will always give you a 0. Right? It's sort of a shorthand to remember it. So for example, if you see a NAND gate, always remember, every time you see a 1 in a NAND gate, you get a 0. Sorry, every time you have 2 1s, you get a 0. Everything else is a 1. Okay? Or you can just learn the whole truth table. Right? You also have this version here. 0 gives you a 1. 0 gives you a 0. A 1 gives you a 0. A 1 gives you a 1. Right? So you have these little shorthand things to learn. And you're good to go. Right? Every time you see a 0 in an AND gate, you know you're going to get a 0. Right? When you finish, next heading, combination gates.
When you join a because he will and yeah.
You know what? I can let you teach your class.
Who, me?
They hearing you more than me. Right? Head up combination circuits. Am I right, Ansel? Combination circuits. We just combine them. Anybody writing online? Emily? Anybody writing? You good? All right. Don't worry, partner. How about it? Yeah, right. Yes, that's the KFC wasn't there yesterday, but it's just a yes, yesterday. And so by a certain height, yeah, so let's just stop it down. Cool. All right, ready? Let's take a look at combination circuits. Number one, let's go real easy. Let's take a NOT gate. Oh, wait. Let me stay quiet. Still in class now? Right. So here's A, here's B, here's C, and here's D. Right? Before you start this, right? I'll give you the options here, right? Right. Before you start, you should always try to label out your gates. Right? That first gate there, next A is what? That's a? No, the one between A and C. A NOT gate, right? That's a NOT gate. And the last gate is a what? The last gate is a? All right. Oh, for years no, is that the AND gate have a straight back. And the OR gate have a curve back. Right? Right, so there's an AND gate. All right, so how are we figuring this out? Number one, to figure out C is the output from a NOT gate, right? Where the input is A. So I'm looking at C. To figure out C, I am looking at A in a NOT gate. All right. So let us begin. Right. One enter NOT gators. One enter NOT gators. Zero enter NOT gators. Sure. Who was here? Just me, huh? All right. Yeah, just leave the down there. Look. And zero enter NOT gate is 1. Everybody okay with that? Online, are you okay with that? Right? You okay with that? How we getting D? How we getting D? We're looking at C and B enter and gate, right? To get D. So we're looking at B and C to figure out D. Right? So 1, 0 enter AND gate. Enter AND gate is what? 0 enter AND gate is 1, 1 enter AND gate is 0, 1 enter AND gate is 0. That's it. That's the way you figure it out. Any questions online? Don't worry, partner. You know that, yeah? If I ask them, how you do Clemens left hand rule? Finish that one for me now. Clemens left hand rule as well. How you do Clemens left hand rule for? Man, right to it. Very good. Are you ready for them? Ready for them. Right. Copy it down. I'll give you the next one. That's number 1. Oh, no. Copy it down. That's number 1. Let's move on. I'll give you the next one. About 3 or 4.
Wow. So what is it? Thank you. You know what?
我感觉我比我手passar a churro. Ei, Rita tá assim, vai lá, deixa eu ver.
You think that is supposed to be? Is it be brown? Yeah. What? You be brown, but huge. Without food, without hey, something here. That's a cream.
Okay, that's it.
Supreme. Smoke.
Oh, it's a goes mathematically. Huh? If I could? And goes like when those show up or something? No?
No, that when you sing, didn't it?
Huh?
Oh, you're right.
Well, I ain't too sure then. Next one. Whatever new meaning.
Like when you're like you don't slow and you're and you don't feel it.
All right, let's go again. Number 2, I'm going to put in 2 NOT gates for you. Hey, Ollie, in front, but Ollie, be recording. You can stay quiet now. Right? Those who are online, all I want you to message me is what he looks like, right? Yeah, this last easy one here. Last easy one. Sorry. Sorry, online. I'm starting over. Sorry about that. Right, so C is the opposite of A, 0, 0, 1, 1. D is the opposite of B, 0, 1, 0, 1. And E is C and D into a NOR gate, which is 1, 0, 0, 0, right? Sorry, they're online. Right, the question is asking, these three gates can be replaced by one gate. What is that single gate that can replace these three gates? Wrong. NAND and gate, yes. Correct. What is here? Ignore this. Ignore that. Look at the input and look at the output. What gate looks like that? AND gates. Does it not? AND gate. All right, let's do one more before I give you a past paper. It's going to be a little bit harder, right? Don't worry, partner. Don't worry, friend. What? But you now say all too easy. And you now say that?
What's that?
Right, try this here, please. Huh? Gosh. What about the TV? Yeah, somebody lock outside. Pay back one hour.
안녕하세요. 나한테 오늘
Yeah. Right. Finish out CD, EF, please. Take quiet.
Speak. What do I need to do? There's things like got to know, go around. Yes. Yes, Nicola, I say like March. Huh? If a fly then we gonna Yeah, I'm just saying, if he wanted to see what I'm doing. It seems like I'm tired. Yeah. Chris, you live in our house? You live in our house? And you see you live in our house. Bagus na kini wala dito. After gabi. Ito sa mga good ka nabang mo din. Yeah, after gabi. Yeah. Ada hindi po. Oo, dahil na well, sure, mga kadiri yun.
I think this is like some Jesus would care. I don't know why I see that. Yes, like very different. When I see the photo, the other way that means maybe it's not right. Yeah, it will be working. Right, do it. Do that. So, Wala nyo oras. Yeah, no, he gets up there again. He's coming over to what's his name? Yeah. No. Yeah, no. Yeah. This is oh, I will let you know. Right on.
No. Right. All right, start with our online. Last one. Right, I see some correct answers already. They are all NAND gates, right? All 4 NAND gates. So C is what? C will be looking at A and B. Into a NAND, so that will be 0, 1, 1, 1. Then I'm looking at A and C to get D. So that will be 1, 0, 1, 1. A and C, right? And then E, I'm looking at C and B. So that is 1, 1, 0, 1. And then F, I'm looking at 0, 1, 1, 0. Right? 0, 1, 1, 0. All right. So that's the way you do your circuits. Right? That's it for logic gates. Let's see if we can squeeze in one past paper and we're done. Pardon me. If we have 8 minutes, you want to do 2 then? Yeah, 8 minutes mean we have real time. 7, well, we can still do 2.
So on my watch, you're doing same fine.
Don't worry, partner. Don't worry, friend. Pardon me? Bye. Right, so this how to work fast. Right? We just have to work fast. Yeah, but gotta get that easy guy a little raise, boy. Try this here. This is 20 Jan 2020. Try this here. Jaden, how you know reach your class, right?
He's like
10 minutes.
and it's only about 8 minutes. I was like, yeah, but it's when I'm just
So you didn't press the cursor?
Yeah.
All right, come on, one question and that's it. Real easy. Finish that truth table. Elena, just you alone. Test 4 weeks this week, every day. Every subject, right? No, just you alone. Don't worry, partner. Hey, last one only. Come on now. Celine, last question. You know, complaining about you only have 5 minutes. Hurry up.
Looking back, you know, learn
anything by looking back now. Channel anything one time now, boy. All right, what's the first one? Right? First ones are not. A not gate. It converts a 0 to a 1.
I think similarly inside and you know.
Oh. Don't worry, partner. Right, and gate. How does it look? 2 lines straight back, no bubble. Right? What does it do?
2 1s to 1.
Changes 2 1s to 1. Right? You can write that, or you can, if you just want something simple, You could write it changes zeros to ones. Sorry, zeros to zeros. Right? Or you could write 2 ones to a 1. OR gate. What you will say about the OR gate?
Changes I want to zero.
Nice. You like this topic, boy. It changes a 1 to a 0. You set him up, boy, a 1 to a 1.
Oh, I want that one too.
Is that a 1 will always give you a 1. Oh, a 1 will always give you a 1. Last one. How you draw the NAND gate? 2 lines straight back and an inverter. Okay? All right, so your homework, read over rectification. Those who now come to class, right? You'll look back at the video from today, right? Okay, next week, test on electricity. Test on electricity next week. And we will start magnets one time. Okay?